How many are we here? I have 17 in the 18. So I assume you got your email announcements from Blackboard. So this link, obviously you registered, is where we are going to, I am going to post all the announcements, the homeworks. It's going to be on Blackboard as well as the quizzes. And review very well the syllabus that is uploaded there. Okay. First off, we're gonna start off with the syllabus and the schedule. So we will go to PowerPoint. And like I said in the beginning, it is a good idea if you can to have Blackboard open while we're doing the lecture, especially in the first hour of the lecture, because that's when we will need Blackboard. Like I said, exams and quizzes are going to be on Blackboard. Also, I know that it is not a CUNY policy that you have to have your videos on, but it is very helpful for me if you have it on, so I will have interaction and I will know how you're moving along with the material. So, and of course, I need the feedback, so that would be helpful. Okay, let's go back to the first slide, which is, can you see my slides? Yes, no?
Yes.
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 Okay, so we have the slides. So, Chemistry in Modern Society. The book is available in the bookstore. It's first edition, and you can actually get the used material very at a really low price. So get the used first edition of this textbook, which I will give to you. So this is our textbook. It's 21st Century Chemistry, okay? And it's in the bookstore. They have used books that are really inexpensive, so please make sure to get it so you have a resource when you're at home doing your homeworks or going over materials and preparing for the lecture class. Okay, so again, Blackboard. If you signed up on Blackboard with other emails, please make sure you use your QC email so it's updated and whatever announcement is on Blackboard is gonna get to you. Okay, your work email, your other school email, okay, change it to your QC email for Blackboard. Okay, for this course, this is the distribution of points. So exams are 65%. We have 2 class exams. So the class exams, topical, cumulative, it's gonna be whatever we discuss up to that point. And we have the dates, it's already posted. I think the syllabus has the updated dates, maybe not, but this slide I am gonna post on Blackboard. So whatever dates I have put in here, this is gonna show up on Blackboard where you can access it, okay? So 2 topical exams, cumulative, and the dates I have set it. So make sure you are available on that date to take the exam. And 1 final exam, which is cumulative of all the chapters. So starting from when we start today up to the last lecture session, okay? That is for exam. And the exam is going to be 65% of your course grade, okay? Quizzes are given weekly. I usually have it at 10. This is an online synchronous class. So we will be meeting as posted on the web, which is 10 to 12:50 Fridays. Okay, so that's what synchronous means. It's gonna meet up at the same time, like we are going to a lecture hall and gathering to discuss chemistry. So 10 to 12:50, and we will meet at this Zoom site, okay? where was I? Quizzes. Okay, so we have 14 meetings, and then the 15th meeting will be our final exam, which I think is the Friday before the final day of exam. So it's in the schedule. I'm gonna show you later. The final exam is the last one. Quizzes are every meeting at 10. So it's a 10-minute quiz, 6 questions. I usually give a bonus, so it's going to be 12 over 10 every time. And since we have 14 meetings, we'll probably have, well, the 2 of those are exams, so it's going to be 12 meetings where we'll have a quiz, and I am going to count the top 8 quiz scores. That's what I'm going to put as your quiz component of your grade. Okay, so like I said, Blackboard, we meet up at Blackboard at 10 a.m. to 10:10. At 10:12, we are going to meet up here to discuss the quiz and do the lecture. Everything clear so far for what's required of you for this course? Yes? Yes? No? Okay. Last part, homework, 15%.
Good.
Homework is also posted on Blackboard. Okay, so homework, I will give you a due date. After that due date, you cannot hand in any of your homework. It's gonna be like a 20-point homework each time. You can ask help, and you can have someone, well, you don't want to have someone. Homework is supposed to help you with the class. So whatever we discuss in class, that's what's going to appear in your homework. So I'm going to post it. I'll post 6 homeworks up. When the due date is up, then you won't see it available in Blackboard. Okay, and that will be 15% of your course grade. And then we'll go by the letter grades from the CUNY website, like how after I calculated your exams, quizzes, and homework, how it's going to be. Okay, this was when we met up. So obviously, you'll have your computer. And this is a chemistry course. And I always tell my students that if you're at a chemistry course, you will need your periodic table. That's our ultimate resource for a chemistry class, and a calculator. So calculator and periodic table. What is this? Periodic table and your notes and your book, it will be helpful. Okay. What is this? So this is gonna be update your email. I talked about it. And going to Blackboard and looking for where it's gonna be. Okay, so make sure your emails are updated. Questions so far? No question? Okay, so this is our class schedule and our exam schedule. So today is August 27. Next week is a holiday. We don't meet up next Friday, okay? Just to update your calendars. So we meet today, we do chapter 1, and next week, next Friday is gonna be school holiday, and then we'll meet up on September 10. Okay, so September 10, expect a quiz on Blackboard at 10 a.m. Okay, on what we covered today. And like during the lecture today, I'm also gonna have you go to Blackboard. Like I said, that's why I said in the beginning, put up your Blackboards, because I want to show you where to find the quizzes on Blackboard. Okay, so important dates, of course, you're expected to be here. Like I said, we are going to be meeting, I think, 13 times. And these are the topics: general science, and then chapter 2, atoms, chapter 3, matter. We go to chapter 4, we skip. So these are the chapters from the textbook that I posted on the earlier slide. Okay, you can find the textbook, a used one, at the bookstore. So September 24, That's our first exam. So that will cover chapters 1 through 3, or wherever we end up in chapter 3. So only the topics that we discussed. So exams are 1 hour, okay? So it's gonna be from 10 to 11 for September 24. And then since we only meet once, remember we only meet once, like 10 to 12:50. So at 11:15, we are gonna come back to our Zoom link and we will have a class and discuss chapter 4. Okay, that is gonna be the setup for this course. So 1 hour exam on September 24, and then we meet up at 11:15, maybe 11:20 to start with the next chapter. And then the next one is November 5. So November 5, we'll cover bonds, gases, chemical reactions, and water. And again, the same thing, 10 to 11, and then 11:20, we meet up for lecture. Okay. And then the final exam, I put in 12:17, CUNY first doesn't have this yet, but I assume since reading day is 12:14, that we usually have the Friday of that week. Okay. It's gonna be on Blackboard, the exams, unless we are asked to have it like a hybrid and then meet up in person for exams at school, but I doubt that's gonna happen. Okay, so exams will be on Blackboard. Any other questions on the syllabus, exam dates? No question? No? Okay. So homework has not been posted, but since we're going to finish lecture on science, I will post the homework one after class. And usually the due date for homeworks is the Monday. It's usually on a Monday, like at midnight, because sometimes over the weekend, like if you're the type of person who does the homework right at the very end, and the weekend you have Blackboard is down, so you have that Monday. But I give you enough time to finish your homework. You probably have it for 2 weeks, okay? So you'll have enough time for homework. Any other question? Okay, no question. What did I have here? So online classes are through Zoom. It's gonna be, there's no lab. This is only a lecture class. The lab has not been offered for a while, but you can ask the department chair if there are enough people that need a lab to satisfy requirements for their programs, then they will offer the lab. I used to teach the lab too, but there has not been enough students that require it in their programs. So there's no lab for this semester, okay? Zoom link, I assume since you're here that you were able to register. Problems with registration? Yes, no? No, okay. So this is where we are gonna meet every Friday at 12, oh no, 10, not 12, 10 a.m. and put your Zoom on. When you do your quiz on Blackboard, it's also gonna be at 10. And like I said, homework is on Blackboard. It's time sensitive. Okay, class quizzes during every meeting, giving once or twice. Sometimes I do a pop-up. It's harder to do it online. But like I said, you take the quizzes and the top 8 is what's gonna be your quiz grade for the course. Okay, so the 3 that are low in score, it's gonna be deleted, not included. Okay, and there will be no makeup quizzes because I will be counting only, I will not be counting all of the quiz that I give. Later top date. So no makeup for quizzes. It's from 10 to 10:10 on Blackboard. Okay. Class exam. So like I said, it's cumulative. So whatever you take, we lecture, it's gonna appear on the exam. Science, chemistry, particularly the beginning topics are a buildup. So whatever you learn in the beginning, you have to retain it. You will need it for the later lectures. Okay, so all material covered up to the previous class will be included for the exams. You must take, so you need to take the final exam to receive a passing grade in the course. So unexcused absences will get a 0. Quizzes on Blackboard, every meeting at 10. Oh yeah, we have a sample quiz later, so you will know how it's gonna be, okay? And then I will make you go to Blackboard. What else? Any questions so far at this point? Okay. No question. Okay. So exams, quizzes, and then, okay, these are pointers. Okay, so here, this is posted also on Blackboard in the syllabus file. So this is prep. Like I said, there are used books for this textbook at the library. It's actually a interesting course, especially now that we're in a pandemic. Everyone is more aware of how science works. And this is consumer chemistry and society. So it's trying to help you think. The cons and the, yes, exams are online. I said that already. On Blackboard, it's online. Okay, where are we? Calculators, we need calculators, the basic one. We need the log. The scientific is when we look for pH. You know what pH is? Who knows what pH is? What's pH?
Oh, me.
Okay. So who the me?
It's like how basic or how acidic a chemistry chemical is.
Okay. So how the basicity or the acidity of a substance. So the acidity level, that's pH. So that's the only time we will need the scientific part of your calculator. It's your negative log of your H+ concentration. So, oh, also, you can rename your Zoom links, because when I'm going to do a poll, so that I will know who took the poll, and then I will also mark it for whoever's in class. Okay. So if you have names that are not your registered name in class, please rename it so that I can mark whatever your names are when we do a poll during Zoom. Okay. Okay. So calculators, like I said, I don't know if there is a $10 calculator anymore. Are there $10 calculators? Yes. Well, you might have calculators from high school. So like I said, we will use this for multiplication, division, and powers probably when we do scientific notation, and the log for pH later on when we talk about acidity. Okay, Blackboard exams are multiple choice or single answer questions. So we will not be doing essays during our exams. Okay. What else? Acidity level. Oh, I have a poll. Let's see. Why do I have a poll? Oh, okay. Let's have a poll. Who's here? Did the poll appear? Let's see what you know.
Yeah.
The smallest unit of matter which cannot be broken down except in nuclear reactions is known as what? Single choice. Who's here? How many are here? 32. That's very good. We are 36, so 32 showed up today. That's very promising. Who's here? Let's see what you know about the atom chemistry. Send in your poll answer. The smallest unit of matter which cannot be broken down except in nuclear reactions is known as what? 26 posted. Let me I'll cut it in 2 minutes. Like I said, answer your poll. I'll use this to Mark, who's in today. 29. Where's 3 more? And 2 more. The poll is online. Maybe you need to scroll your web thing. Everyone sees the poll. Well, only 2 haven't answered. The poll, where do you see your polls? It's a pop-up. On Zoom. Did you see it? Everyone sees it? 2 still haven't responded. Okay, so I'm gonna have another poll again, so you'll have another chance. But share results. Okay, I'm gonna put in Christopher. I'm gonna have another poll again. And if you have a lot of windows open, maybe it doesn't show. So make sure you close other windows so the pop-up comes and you can actually see it. But I'm gonna have another poll during the lecture. So what is the answer? 80% says atom. Is that correct? Yeah, the atom can be broken down by nuclear reaction. That's why you have your bombs. If you have to bombard it with really high energies. But when we do it in the lab, your lab bench experiments, then you cannot divide an atom. Okay, nuclear reactions, you have your atomic bombs, that's what happens, but you have to input so much energy to break up. Okay. Okay, so I'll be doing this a long lecture, so I'll know who's here, and also I'll know if you know what's going on, what I'm talking about. Okay. Okay. Okay, and Christopher, look up for the pop-up because I am going to have another poll and make sure you have it. Stop. What is this? Okay, so before we go on to the lecture, Jeffrey's here. Do you have something to share or introduce about your project and demos to help with this course?
Yeah, good morning. I'm Jeffrey. I'm an undergraduate student here at Queens College in the chemistry education program. And part of my work this semester is going to be doing some demonstrations for this course, showing some experiments that are related to some of the material that you're learning in the lecture. So you can kind of see how that works in a laboratory setting. So hopefully you guys find that interesting. I'm not going to take up any more time, so thank you.
Okay. So Jeffrey's going to do demos of reactions that we will discuss in class maybe. Before we had a demo at the end and we made ice cream from liquid nitrogen. So that was fun. But we can't do that right now. Maybe soon it's gonna change. So he's gonna try to show you an actual reaction, okay? So, or energy, for example, what happens, or colors, what happens when you bombard a chemical, and then how does it go back to its ground state, the unexcited state. Okay. Any questions on the syllabus and on the course material, the grading part? No questions. Oh, I want to, wait a minute. I have to open my syllabus and, okay, for the exams, I just want to post it up. My exam policy for, like I said, we talked about you cannot miss the final exam if you want to get a passing grade in the course, but also, where is my syllabus? Syllabus is posted online. It's going to be the same as what I have here. So make sure you review your syllabus. It's on there. Okay, this is important. So I'm going to share this with you and read it to you before we go on the lecture. So class exams, this is the syllabus. And like I said, this is posted on Blackboard. Who went to Blackboard and check on the syllabus? Did I put the dates on the syllabus that I posted? If you checked it? Oh, yes. Oh, good. It's updated. Very good. Good job checking your syllabus. So everything that is pertinent to the class is going to be in here. So class exams. Students are expected to take each exam. If you must miss an exam due to an actual emergency, the exam may be waived, okay? If I determine that it's warranted, there are absolutely no makeup exams. So students who miss an exam, the final exam will be counted as 200, okay? And that will be what will count as the exam missed. Do you understand? So if, for example, you miss one exam, there are no makeups. Your final exam will count twice, okay? The final exam is cumulative, and you must take the final exam to receive a passing grade. So this is important. So that's why I wanted to read it to you. Detail policy. Okay. Question? And also we'll have a mini break in the middle. It's like a 3-hour stretch. So we'll have a stretch break in the middle. Okay. So like I said, 33 are here. Okay. Like I said, this class is hopefully help you how to think, okay, as a consumer. We're all consumers, right? Buy. I have sons. They have money. All they think is what Pokemon card they'll buy next, or what Roblox or Minecraft or whatever they can spend their money on. So this is all we are, consumers. What's the newest thing that we can buy? So this is a class that tries to make you think. So general thing. Do we use what? Plastic cups or paper cups? Which will make it more environmentally friendly. So it's pros and cons of what is out there, which is what we are trying to do. So as an intro, we are going to look at chemistry. And this is our poll. An atom is the smallest unit of matter that cannot be broken down except in nuclear reactions. Okay, so chemistry is everything. Okay, what is chemistry? What is matter? Matter is essentially chemistry. In high school or in previous classes, what would be the basic definition of matter that you can remember? It's been drilled in your heads. What is matter? There's a static. I
My
can't.
man's just on a helicopter.
You're in a helicopter?
Nah, it just sound like it.
Okay.
Anything that takes up space is matter.
Okay. Anything that takes up space, so volume and
Huh? That's all I remember. Sorry.
okay, that's one part. What's the other part? Takes up space and has
Anything that has volume and mass.
mass. Okay, so anything that takes up space and has mass. So tangible material. So everything around you is matter. If you look around you, everything is matter. Okay. Study of the composition, structure, properties, and reactions of matter. It's around us every day. So that is what is chemistry. So here, everything here that we see is matter. So what do we see here? So like talking about a consumer, we were watching Ant-Man. And so the theory of Ant-Man is they like squish in the atoms at the distance are so close to each other, right? That you become really small. And like, why is it that you can pick up a little goat when it should be the same? So we were talking science while watching Ant-Man. So anything, so atoms make up matter. Atom is the tiniest part of matter that cannot be broken up unless you have a nuclear reaction. So this is Mentos. Mentos you can use for what? You can use to fizz. I
Yeah,
have
get some Coca-Cola.
yeah, a backyard chemistry show, which is what I did for my kids. You can, yeah. Wear goggles, safety first. But no, this is Mentos, and this is actually an antacid, okay? What's an antacid? We talked about pH. What is an antacid? Is it acidic or basic? It makes the pH more basic, right? It's an antacid, anti-acid. So what is the function of an antacid?
It increases the pH.
It increases the pH of,
I guess whatever substance it's in.
okay, whatever substance it's in, but primarily the function of an antacid is to,
Oh,
wow,
isn't it like for your belly?
for your belly. Your belly has a lot of acid.
Yeah.
So that's what it's trying to increase the pH of. So pH higher than 7 is basic, pH lower than 7 is acidic. So when you take in antacid, usually the active ingredient is what? Calcium carbonate or magnesium carbonate. So what does it do? What is it doing here in the glass when you put this antacid in a glass? What do you see? The water. It's dissolving. What else? As it dissolves, it fizzes. What does fizzing tell you? Fizzing means what?
Isn't it like releasing oxygen or like air or whatever? Because there's a bunch of bubbles.
It's releasing a gas. You
Yeah.
think the gas here is oxygen?
Nah. To be honest, like looking back at it, nah. Doesn't
If
have
it's
to be.
oxygen, it would like be combustible, right? Oxygen. You don't want any oxygen tanks around open flames. But what do you think is the gas that's being released here? Carbon dioxide, very good. So if you have a tummy ache, you don't feel well, it really hurts, you take in an antacid, what do you hope will happen? You hope that you will release gas, right? So then you'll feel better. That's the function of the antacid. Release of gas, both ends of your digestive tract, right? That's what you hope. So you burp or you, favorite word of my kid, you either burp to release gas or you take it out the other side of your GI system. So these are all matter. The glass, the water, the antacid, matter, this is chemistry. Okay? So everywhere around you, that's chemistry. So here, another word for all substances, antacids, water, glass, air, carbon dioxide, that's matter. Air around you is matter. Air is a mixture, which we'll also get into it. Classification of matter. So if you look at toothpaste, you have chemicals. If you look at the back, the ingredient list, you will see all the different substances that the toothpaste is composed of. Okay, and those chemicals are substances that have the same composition and properties wherever found. So it's the same substance, same chemical. Sometimes substances that are made in the lab. So in the lab, you do it synthetically. It's made in the lab or naturally, natural products, okay? So sometimes you can tell that that chemical substance is there by the color. For example, when you talk about antioxidants, these are a group of chemicals that will what? What does antioxidants do? What is a chemical reaction that happens to our body? What is a chemical reaction? Why do you take antioxidants? Why do they say it's good for you? What are antioxidants? Who can give me an example?
Strawberry.
Strawberry.
Oh, blueberry.
Blueberry,
A lot of
yeah.
berries, actually.
Blackberry, those purple colored, violet colored, usually they have antioxidants. Red cabbage has antioxidants. So you know that a certain substance, these are anthocyanins. Antioxidants prevent, as the name implies, what does it prevent?
Oxidation.
Oxidation, antioxidant. So essentially when you age, you're oxidizing. That's why on the skin, you put on stuff on your skin so that you won't show too much aging. You're trying to slow down oxidation. So all these substances, and like I said, sometimes you can see what kind of substance is there by the color of the product. And toothpaste is where, if you look at the back, you can see a lot of chemical. Is that why people, oh, really? I haven't heard of that. Maybe avocados is a really rich protein and fatty, like oil. Maybe it's just the oil for avocado. I don't really know.
Well, what don't we put avocado on these days? Not gonna lie.
Heard
Like,
of avocado on the face. Okay, that's some, really? Maybe it's just a film, so I didn't know. Okay. Yeah, but it's still like messy to put on avocado. Well, everyone has avocado toast. Toast with avocado and a gooey over easy egg. Mandarin too? Softer? I don't know. I didn't know all these beauty regimen. Okay, something new. Well, we're a consumer, whatever works. Okay, I'll try it. Right, consumer chem. So what? Oh, and banana too. Well, at least we're going natural. We use up whatever supposed to be a byproduct, a waste. So you put it on your skin. Who knows? It might do something. So where was I? Chemicals are everywhere. Sometimes they're made in the lab, and products outside, usually what you make in the lab is to mimic what's in nature, right? Yeah, use the whole garden. That's what you're trying to do, intensive farming. So you put out, like in a little space, you plant whatever is useful to you. And you, if you look at square foot gardening, right now my garden is dying, but you use the available space you have to try to grow whatever. Okay, so this is an example of what might be in a toothpaste. So at the back, you have all these. These are the chemical names in words. By the end of the semester, hopefully, we will learn how to write these chemicals in what? What is the purpose? At the end of the course, you will learn to write these chemical names as formulas. So you write it in formulas. It's going to be a shortcut, and you actually will know what are the different atoms found in each chemical. Okay, let's guess. The one that is really obvious would be calcium carbonate. What? Talking about periodic table and calculator at each lecture session. First chemical here. Who recognizes an element here? Calcium carbonate, Ca, right? So calcium is an element which we'll learn later on and where it's situated on the periodic table. So many things, and each chemical has its own function. So they put it in. And even if you have a product that's very useful and it functions very well, you also have to have a consumer response to it. If a consumer doesn't like to use the product, then no one's gonna buy it. Carbonate 2, CO3, yeah, that's another. Then no one's gonna buy it. So in addition to functionality of a substance, it has the consumer has to be receptive to it. Titanium dioxide. Okay, this one, where do you see this? Especially during the summer. Where else do you find this chemical? Titanium dioxide. Sunscreen, very good. So titanium dioxide is a pigment. And actually, what does it do? Why is it in sunscreen also? What is the function of sunscreen?
It blocks UV radiation.
It blocks UV rays. So what do you think titanium dioxide does?
Exactly that.
So it's gonna form a layer on your skin where the UV light cannot penetrate.
Oh, that's why people be looking like purple when they wear it sometimes.
Okay, no, but that's like the white stuff. So that is what you have on your sunscreen. So it's also like makes toothpaste white. And you have here the antibacterial and methyl salicylate, so that you want to brush with it, although some doesn't like the mint taste, so they don't want that. So these are just examples of chemicals that you find in toothpaste. Okay, in the kitchen, you have all these chemicals. Glass is silicon dioxide. Where is glass made from? What do you think glass is made of? Sand.
Like sand, yeah.
Very good. Sand is silicon dioxide. What do they do to make, to convert sand to glass? What do they do?
Burn it.
Burn it. Yeah, it's actually pretty cool. When you go to a brewery and they make those beer bottles, you see an orange glow. Minecraft. Oh, don't give me any more reasons to have my kids use Minecraft, because they're gonna like be in their own world and look at all they tell me that they have emeralds and gems there, so they know chemistry if they go play Minecraft. That's what they're gonna tell me. And all the limestone and whatever they find in Minecraft. But back to sand. Sand is silicon dioxide. Silicon is an element, oxygen is an element. You apply high temperatures to sand, it's gonna turn into glass. So if you get a chance, go to a brewery that makes their beer in-house, or if they use glass, it's very cool when they make those beer bottles from broken glass. Polymers. What are polymers? We're gonna learn about is natural gas. What natural gas do we use? It was when it was new, the buses had a very big signs on the side, powered by natural gas. It's a propane, you use propane, yes. Propane usually use for the temps when you have grills outside, or sometimes natural gas, you use methane. Butane you use in the lighter fluids when you go camping. That's what you have in the little bottles to start. Ethanol, okay. So methane, okay, this is gas. So ethanol, when you talk ethanol, usually at liquid state, ethanol is what? Oh, liquid state, room temp, it's gonna be liquid ethanol, okay? That is what we use as an antiseptic, okay? So these are all chemistry here. The waxy thing that is put on apples so it does not oxidize fast, it doesn't decay, it's also a chemical. What is fire made of? What is fire made of? Fire is what? When you have three things together: fuel, oxygen, and what? Something to start it. Then you have a fire. So you need to remove one of the three things so that your fire is going to stop. Okay. Questions so far? What is chemistry? The slides are clear. You can see everything. It's clear on your screens. You're following with the lecture. Okay, good. Okay, the scientific method. This is Linus Carl Pauling. He won a Nobel Prize. And so he won a Nobel Prize in 1954. So what we're talking about in the following slides are how scientists go, to discover something, or maybe usually when the ones that have big impact, it's because of serendipity. They're working on something and then, like penicillin, and then it happens. So thinking like a scientist. So this is Linus Carl Pauling, and this is how scientists go about. Oy, geez. Okay. So what happens here is you observe something going on, and then it's repeated. And then you say, okay, maybe that's why it repeats like every time it happens because of this. And then you repeat it again. There's a lot of repetition when you try to figure out something, because you want to know that your guess, your good guess, your educated guess is what's actually going on. And then when you're sure, then you come up with a conclusion. So that is the scientific method. First, you observe, observation, that something happens. Then you propose what is going on. Oh, so there's a journal, the Journal of Irreproducible Results. You know, the the Nobel Prize, there's also an Ig Nobel Prize. Random things they put up on this journal. Like, if you look at statues, why do pigeons poop on one statue more than the other statue? People actually study these things. And there's a journal that has that, that material is welcomed. Okay, a lot of things that you observe and you want to know the reason why, you can do it. So that's just one example that comes. Why do pigeons poop more on this statue than that statue? So same thing, you apply the scientific method. You observe something, you make an educated guess, you do the experiments, see if what you think is happening is what is really happening. So this is also a study that the buttered side of a toast always is the one that falls right on the floor every time. And then, is a hot dog a sandwich? What is your definition of a sandwich? That's why in the beginning you have to have definitions of terms so that everyone's on the same page of what you mean. That is also important, communication, right? So that is also important in the scientific method, that you define terms and define conditions also, variables. So this is your scientific method. Observation, hypothesis, you do the experiments, and at the end you have results, the conclusion after your experiments. Okay. There's an open sandwich. What is that? Why do they call it an open sandwich then? If a sandwich, you need to have something squished in between. They have these open sandwiches. It shouldn't be an open sandwich. It shouldn't be called a sandwich. So anyway, okay. This is the scientific method. Another example here, observation. Your friend has a new cat, and then you're sneezing. So you think that you're allergic to cat hair. And then you go to other friends who have cats. And then if you feel sneezy, then that means that maybe you are allergic to cats. So that is your conclusion. So when you want to learn about something, you apply your scientific method. So like when you say, apply and think about the things in a logical manner. So essentially you're applying the scientific method. You observe something, you guess what's going on, and then you do experiments. Okay, observe, hypothesize, experiments, results, and conclusion. Yeah, that's the summary. So this is the picture of what's going on. And what she did was went to sometimes, well, we have 3 cats. So we have friends who can't come into the house or take a lot of antihistamine before they can come in the house. But during pandemic times, it's good that no one comes in the house because, you know, you're more comfortable when you meet up outdoors. So with the pandemic, we've known most of the neighborhood preserves or state parks or bike trails or hiking trails, because that's a place where you can meet up outdoors in the pandemic times. Okay. Questions? This is the summary. And sometimes your conclusion does not make sense, so then you have to find another hypothesis. So you do it over again, or your experiments doesn't fit the trend. It doesn't follow a trend of what your hypothesis is. So you have another guess. So this is the scientific method, thinking about things logically. Okay. So you modify the hypothesis if the experiments don't support your hypothesis. Okay, study check. See if you're following. Identify each of the following as an observation, a hypothesis, an experiment, or a conclusion. A, during your visit to the gym, your trainer records that you ran for 25 minutes. What is that? Observation, hypothesis, experiment.
Observation.
Okay, everyone says observation. Okay, let's put that in our heads and we'll look at the answer. You think your trainer records observation. Everything says observation. Okay, what about B? Scientific studies show that exercising lowers blood pressure. B most says conclusion. Why do you say B would be conclusion? Who wants to say it to the class? B. B is conclusion. Why? Hey, you're all too fast for me. Oh, I'm still on B. Why are you on C? B is what? Why do you say it's conclusion? Studies show. Very. Ryan. Ryan. Ryan, R-A-Y-A-N. I saw a raised hand. You can actually, oh, the mic issues are, oh, you raised your hand. You know, you can raise your hand. So the important thing is like Christopher pointed out, it said studies show. So show that the studies have been done already. So it's a conclusion. So these are your markers in the statements. What about C? C is H, hypothesis. Why? Why would it be H? Thinks.
It would be H
okay?
because he observed that the weight loss was because of the exercise.
Okay, so he thinks. That's also your signifier. That ding, that's the thing. Let's see. So were you correct? Yes, you got your answers correct. So observation for and B, it shows. C, your doctor thinks. Hypothesis. Okay, question on the scientific method? No? No? Raise hand if, okay, pretty straightforward, good. So moving on. Oh, I have another poll. Okay, Christopher, are you the one who didn't see the poll in the beginning? Yes, okay, I'm launching it now. Do you see it now? Still no? What device are you using? Maybe someone who has the same device as you would know where to look for it. A laptop? Laptop should pop up, right? Hello? Can anyone help Christopher? He's not seeing the poll.
look under more, right where it click more, and then where it says chat, right above chat, it says polls.
Okay. Christopher, did you hear? Click more, it's right above the chats. Well, I won't know where it is because I'm the one doing the poll. There's more on the side. When you go to the Zoom toolbar, you have more 3 dots, 1, 2, 3. Click it. And you should, Christopher, stay after class and maybe I can help. More is always on the Zoom link. It's when it doesn't all show on the toolbar. Okay. Oh, so stay after class and I'll see if I can help you with where to look for the poll. Because more is the 3 dots. Okay. Who wants to discuss this? Which one do you think? Oh, I didn't share the results. Which one? Yes, Brian Lynn. You have the Zoom floor or whatever. What do you think? Okay. Everyone agrees option C is more of an opinion rather than a hypothesis. What would you, 2 participants raised hand. Who raised hand? Brian Lynn. Ryan, R-A-Y-A-N.
I think another thing, definition for the hypothesis would be something that can actually be proven using a scientific
Very good.
experiment. And that dogs are better than pets.
Did everyone hear what Ryan said? Is that how you pronounce your name, by the way?
Yes.
Yes.
Yes? Everyone's
Yes,
agreed?
correct. Everyone.
Okay. So when you have a hypothesis, you should be able to prove it by experimentation. How can you experiment? People are subjective, right? I like dogs. I like cats. I like both cats and dogs. So that would be the best choice for figuring out which is not a hypothesis. You following? Yes, no. Yes, okay. Okay, so when you make your educated guess, you have to be able to do studies on it. You have to get your data. Okay, very good. Okay, so that is the scientific method. And then back to here. So a general approach for used worldwide, like I said, you have to have communication. You need to know, okay, what is the other person is. That's essentially what you need. That what you're doing here, you can communicate to other groups of scientists doing the same thing, so that you know what your variables are, what the conditions are. Okay. So each scientist addresses only a small part of a larger problem. Now you'll have more of a group approach right now with scientists. like in a certain group, before you would have just chemists, just physicists, and now you have everyone like working together, and each has their own part and each can share. And after they do a study, they review it and they submit it to a journal. So a journal has also different levels of audience, okay? And what is more reliable journals that you can get information from them, okay? The reliability of the journal. So you have points that you consider. So, so this is the next step after you come up with your conclusion. So you have a question, you write it down, you give it to a journal. There's an editor of a journal who gives out the articles to different other groups that would review it. What are the steps here? Is this work a good work, or maybe they just copied from another person's work, okay? You hear from the news, plagiarism, or also in the universities, you have plagiarism. So plagiarism, you're copying data from another source. You didn't actually do the work. So that is important in, to do your work. So if everyone agrees that this is something, the work is something that should be published, and it has meets editorial and peer standards, then you publish your work, okay? And hopefully it builds up to whatever work is on your field. If you look at your textbooks, one line on a textbook, so many people worked on that. To have now, probably it's going to be a statement in your textbook, whatever textbook you have, each line on your textbook, a finding, for example. So this is the scientific method. Okay, and when you do the scientific method, you can do the wet chemistry lab work, or so when you do chemistry, you just want to see, like you also have not just the work, but everything that would be involved in the work. Your chemicals, the energy input that you need. Okay, chemicals are expensive, like the equipment that you need. So you have to think about all these things. And like just focusing on the chemicals, sometimes before you do and go on a big project, you do the quick and dirty. You just mix things together and see maybe from change in color that, okay, this materials work. And then you can buy those expensive chemicals before you do it very detailed. Or you can also do theoretical studies, computer simulation. So you put in the substance name in a software. And what goes on here is, instead of doing all the lab work for all the chemicals that you think will work in a project, you put it in a software, a computer, a molecular modeling software, and then you put in the chemical name, and then you make it go through the reaction, the chemical reaction, and you see which chemical is most likely to work on your reaction. So instead of going through the 20 substances and doing, oh, maybe 50, maybe that's your pool, 50, then you only have to do the wet chemistry for 20 substances, okay? That's not artificial, it is input, information input, that you will still go through with wet chemistry. And then the 20 that you did with your theoretical modeling, you actually do the lab work and see what happens when all the variables are taken into account. So this is very helpful, computer modeling. It's not artificial, it's a helpful tool to narrow down which materials you use, especially if you're a new, for example, you're a new professor and then you don't have any money. So you can ask, or if you have an experience in computer modeling, molecular modeling, then you can do this. And then instead of buying all of the chemicals that you think from your research would help, then you would only do the 5 that is most likely to work for you in your reaction. Okay, do you know what I mean? Yes, no? Computer modeling, theoretical modeling? Yes, no? Okay, I see a yes. Other yeses? So this is computer modeling. Okay, this is also a big field, especially in pharmaceutical industries. They have computer scientists, theoretical molecular modeling people who do this. Okay, they work with a program, or they come up with a program to figure out what's going on when the drug comes into a system, the proteins that they attach on, if water is there, what happens with the drug that they're actually making. Okay, so this is all part of the science world. You have your wet chemistry, you have your computer molecular modeling, and it's all there. Okay. Okay. There will be no class recordings. This is a synchronous online class. So we come and meet like what we do in class if we meet up at Queen's College. Okay, also, the things that you cannot see with your naked eye when you don't have high-powered machines, microscopes, you can also do with computer modeling. Okay, experimentation. Later on, we'll talk about quantitative data, qualitative data. That's the data that you need when you do experiments. So this is like a jump to the next topic. But when we look at data, especially with atoms you can see with the naked eye. So look, like this number, 7.9 times 10 to the 24. In a glass of water, what is a glass? We define a glass that has a volume of 8 ounces, 237 ml. In one glass, if you put water, in that glass, you have 7.9 times 10 to the 24 water molecules. Is that a big number or a small number? 7.9 times 10 to the 24. It's huge. Okay. 10 to the, that's more than everybody living in the earth. 1 billion would be what? 1 times 10 to the what? 1 billion.
6.
Is it
Actually,
6?
no, that's 6. My bad. That's like 9 or 10.
1 time, how many zeros for 1 billion? How many zeros? We're gonna, this is where we're going to.
9.
Huh? 9.
9.
So 1 times 10 to the 9. So this is how you deal with very big and very small numbers. Okay, what is it? At 11:15, let's take a 10-minute break. Okay, so that you can stretch, and we come back at 11:18. So we'll finish. So this is the following slide. We're talking about data and how to record data. And if we come with very big and very small numbers, then we look at, so this number here, that's called the scientific notation. Okay, this is at base 10. So this is times 10. 10 to the 24, what does that mean? This is what we're going to learn about. So if you look at this water, okay, that's how many molecules. Later on, we learn what molecules are. Molecules are composed of atoms. Atoms are very tiny. So very large or very small numbers, you use a scientific notation. Here, your hair is 8 times 10 to the minus 6, really tiny. The more plus, okay, that's a big number. If you see a minus, that means how far away from your decimal point. That's really tiny. So 8 times 10 to the minus 6 is a really small number. She has every hair strand, she has 10 to the 5 hair strands. That's how many hairs. While the diameter, the width is what? 10 to the minus 6. That's the, like, if you have a high powered microscope, that's what you will measure. Okay, so people have an average of 10 to the 5 hairs, and the width of the hair is 10 to the minus 6. Okay, and why do we write it this way? So we do not have to write all the zeros, and that's what we're going to learn, how to write things in scientific notation. And with that, let's take a break. Be back in 5. And so I'll stop here.